finding the inverses of more to one functions. Right, now for more to one functions, there's two types of more to one functions that you work with. The first one is the parabola, and the second one is the cubic function. Luckily for you, you're not expected to find the inverse of the cubic function and to be able to sketch that. So if we work with more to one functions, there's really only one thing that you need to learn, and that's the parabola. Alright, now I just want to explain to you the basic concept first again, which I have touched on in the basic video. When I find the inverse of a function, I reflect on this y is equal to x line. I reflect in this line. Right, and can you see if I take this part of this parabola here, this half of this parabola, and I reflect this in this line, that this part will go there to that axis. If this, say for instance, go through -4 here, it will go through -4 there. So can you see that this part will reflect there in this line, that side and that side, and this part here in this line will reflect about there. Can you see? So this part will probably reflect about there, like that, right? So there's a rough reflection, can you see, of this line here. If I reflect it in this line, should go and lie there, right? And then let me use another color pen. If I reflect this part of the parabola, I'm going to draw it up until that line for now. If I reflect this part of the parabola, it should rough in this axis, it should look like this. Can you see? If I reflect this here, it should go there, and I know it's part of a parabola, so it should then look like this, also through -4. You see this part of the parabola reflected in this line looks like that, which now if I look at my new parabola should lie around there, right? It's just important, you're not supposed to be able to do it like this, but it's just important for you to know that when I take a parabola and I find the inverse, it's going to flip to the side. That's important, first of all. And second of all, can you see that if I look at my x-axis, this is my negative x values and my positive x values, that my negative x values, which is the red part, will also be my negative y values in this parabola, and my positive x values will be my positive y values in the second parabola, the sideways parabola, like that, right? And then another important thing is, if I find the inverse of a function, I actually want to find the inverse, and my new function should also be a function. Now you hopefully know already that if you find the inverse of a more to one function, the new relation is not a function. So this sideways parabola, if you only focus on that now, or I can maybe just draw the sideways parabola there in green, the whole one inside, on the inside of the lines, the green one, that's my sideways parabola. If I do the vertical line test on it, can you see that at some points it cuts the vertical line twice? So this is then indeed not a function. But the purple part of this parabola, the top part, is a function, and the bottom part separately, if I look at them separately, are functions, and that's where my restriction comes in. And for restricting, it's just important to know that I took the negative x values to make this part, which is a function, and I took the positive x values to make that part, which is a function. Alright, so if you have that concept, and you know that when I do the inverse, I swap the x and the y values. So if I restrict my original parabola, which is this parabola here, if I restrict that, I can either restrict it from this line, that's not right, this pen is not right, from negative infinity up until 0, that's the negatives, that's x values. So I can either take my x values in this parabola, all the negative values, or I can take all of the positive x values, and that will generate, if I only take the inverse of this part of the function so that x lies between negative infinity and 0, which is the red part of this function, then my inverse function, I will have a restriction on the y values, because in the inverse I swap the x and the y values. So then my y values can only be negative values, which is that part. And if I have in my original function positive x values, which is this, then in my inverse function my y's will have only positive values. So this is important, right? And from there on we can do, if you just grasp this concept, we can do a few examples just to show you how this works. Exactly. So say for instance, I've got the function y is equal to x squared minus 4, right? And for this, we're not looking at graphs that has been moved left and right. It's all the turning points lies exactly on the x-axis, so that one part of the function is negative x values and the other part of the function is positive x values. So if I look at this, what will happen? To find the inverse of this function, I'm just going to ignore the restrictions for a second. To find the inverse of this function, you'll do exactly what you did in the one-to-one functions. I swap the x and the y values like that, and then I get y alone. Now to get y alone, I've got y squared is equal to x plus 4, like that. I just took the 4 over, or you can write it like this, y squared is x plus 4, because I want the y this side usually, but it doesn't really matter. And then I just take the square root both sides, but when I take the square root, remember it must be positive or negative. Square root of x plus 4. Right, where the positive square root x plus 4 will be that part of the graph which comes from your positive x values, and the negative square root of the graph will be that part coming from your negative x values. Alright, so if I now, so this is how I find the inverse of this function, and the only thing that still needs attention here then is the restrictions. Now, one thing I can do restricting this is I can work with the negative x value. So here at the beginning I do exactly what I did, but in my original function I restrict the x values so that they are only negative. This is the first thing I can do, right? And then from that, in this function my y values will be negative. Right, now since my y values are negative, when I get here I just say but y values are negative, so therefore my y should be negative root x plus 4, and if I go and draw it on a graph, then it's just that bottom part of the sideways parabola. Alright, so that's the only thing that's actually extra. That's the first choice of restrictions that you can do. The second choice of restrictions that you can do is you can take the positive x values. So say for instance I took the positive x values, I said x is an element of 0 to infinity. I see this pen is a bit dirty. And then in the inverse function, that will mean that my y values should be an element of 0 to infinity, because my x and my y swapped. So just what was the restriction on the x now becomes a restriction on the y. And when I get to my answer, I just say again, oh, my y values must be positive. I did write it up there, but I just say that again here, and that means then that I will only have the positive values of the graph, not plus or minus, just the positive values of the graph. And then this sketch will only be that part of the graph, this sketch being that part of the graph. All right. So that is the restrictions is the only thing that's really extra in finding the inverses, and that is how they work. Let's quickly look at another example, and we're going to do restrictions also, but now you know your y value at the end should give you an option of positives and negatives, and then you just restrict the y so that it only includes the positives. So say for instance I've got y is equal to 16x squared, then my inverse function will be x is equal to 16y squared, and then 1 over 16x will be y squared. I just divided by 16 both sides. You can write this as 1 over 16x or x over 16, same difference. 1 over 16x and x over 16 is the same thing, right? And then I'm just going to find the root. Now, I know I will have positive and negative values, and what the root of 1 over 16 is 1 over 4, so I can actually write that outside the root, but let's write it inside first. 1 over 16x. Now the root of 1 over 16 is 1 over 4, and then you can just leave the x inside the root actually like that. Okay, so this is my function. Now if they said use restrictions, or if they say find the restrictions, now I must go and find the restrictions. If they didn't say anything about restrictions, don't leave it like this. Then you must actually from the beginning do the restrictions with the problem. Alright, so let's just add the restrictions, and if they don't say anything about the restrictions, you can draw either side of the graph so that it is a function. Usually the positive part. So they didn't say anything in the question about restrictions. They just said sketch the inverse function of y is equal to 16x squared, and the inverse function, so that the inverse is a function, I must restrict this. So then I can use either one restriction, I don't need to do both, and then I can just say, okay, so I'm going to restrict x so that it's positive, so from 0 onwards. I have this function, but only the valid for the x value is positive. That means I only take this part of the parabola, the positive x value part. And then if I find the inverse, then in my inverse I will have the restriction that y is an element of 0 to infinity, like that. Or you can write, if you prefer the notation, y is bigger than 0. X is bigger than 0. You can use that notation also. Alright, and then when I get here, since my y is positive values, then I can just say, okay, so y should be positive a quarter, root x, and I don't need to write the plus there, but I can just throw that signage away because I'm not going to use negatives anyways. I have a restriction on my y value. Right. I don't know if you can hear the rain in the background, but it just started raining and it's dripping and it's wet. It's great. There's this fresh smell in the air now. Everything is so new and divine. It's actually awesome. Alright, so that is how this will look like. I just put this in a different color pen so you can clearly see how my problem changes from the normal one-to-one function to the more-to-one function. This is what's extra in more-to-one functions. You don't really need to go and write that in extra pens, in another colored pen, and you are more than welcome to start filling this in from the beginning. If you tend to forget filling that in, just add these 4 lines at the end. First do the problem and then just add those lines. Right, let's look at one last example. I'm going to do the restrictions from the beginning in this example so you can see them. But hopefully you've got the idea now anyways. Right, so if I have y is equal to 5x squared minus 12. Right, now I know this is a parabola, and I see parabolas are moved sideways by the p-value, if you remember. I see there's no p-value, so this parabola lies exactly on the axis. Which means the one part of the parabola will be in the negative x values and the other part of the parabola will be in the positive x values if it lies exactly on the y-axis. So I can immediately say put a restriction in. I can use x is bigger than 0, x is real numbers bigger than 0. Alright, which is the same as from 0 to infinity that I used in the previous examples. So I use the positive x values. Then if I find my inverse, I'm going to swap the x and the y. So I've got x is 5y squared minus 12. And I will then have the restriction that y should be positive real numbers. Right? And then I just want to get y alone. So I've got x plus 12 is 5y squared. So I divide by 5 both sides. So I've got x plus 12 over 5 is y squared. And then y is just the root of that, positive or negative root of x plus 12 over 5. Right. And I can really leave it like this. Right, but now I remember, oh, my y value should only be positive real numbers. So that means that my y in this case is then just plus x plus 12 over 5 plus the root of that. Right, you can also use the negative one, it's your choice. There's 2 choices and you can use either one. The usual one that we will use is the positive one, but you can make this negative smaller than smaller than smaller than. Then you just have to place a negative there in front because then you chose the smaller than 0 root, so you've got the negative answer option, which is also a function anyway, so that's also fine. Alright, so there we go with finding the inverses of more to one functions.